last class we have seen the proof for the generalized principle of inclusion and exclusion. So we have got E of m equal to summation k equal to m to q minus 1 whole raised to k minus m kcm omega of k. So let us see a few results from this theorem. So corollary 1 I have. So if E of m is equal to this, then E of 0 will be given by summation k equal to 0 to q minus 1 whole raised to k, k is 0 varum omega of k. So you know k is 0 is equal to 1, so you get k varies from 0 to q minus 1 whole raised to k omega of k. So that is going to be omega of 0 minus omega of 1 plus omega of 2 minus omega of 3 plus etc. The last term is minus 1 raised to q omega of q. So this is going to be the value of E of 0. So E of 0 means that counts the number of elements which possess none of the properties. Okay. So E of 0 will be given by this summation, and now let us see the next corollary. So corollary 2 states that so let A1, A2, etc. AQ be any Q subsets of a finite set S then cardinality of A1 complement intersection A2 complement intersection AQ complement is given by cardinality of S minus summation I equal to 1 to q cardinality of AI plus summation over I less than j cardinality of AI intersection AJ minus summation of I less than j less than k cardinality of AI intersection AJ intersection AK plus etc. plus the last one is minus 1 raised to q cardinality of A1 intersection A2 intersection up to AQ. So here AI bar denotes the complement of AI in S. So that is the second corollary. So if you have the subsets A1, A2, etc. AQ of finite set S, then we have the formula for the cardinality of A1 complement intersection, A2 complement intersection, etc. AQ complement. Now let us prove this result using the corollary 1. So we corollary 1 in the form we properties define and then we will obtain this result. So for the proof, so let me define first of all the properties. So the properties define so I have the subsets A1, A2, etc. A, Q. So X is said to possess the property Pi if X belongs to the set AI. Okay. So all the properties P1, P2, etc. PQ are define the properties. So X will possess a property Pi if X belongs to the set AI. So let me define the properties. So for each I equal to 1 to extra q, define the property Pi by saying that an element x belongs to S satisfies the property Pi with the name x belongs to the set A. And now we need to find the cardinality of A1 complement intersection, A2 complement intersection, AQ complement. If x belongs to AI, it is said to satisfy the property Pi. So if x does not belong to AI, it does not satisfy the property Pi. So when you take this set A1 complement intersection, A2 complement intersection, etc., AQ complement, so it possesses the null of the elements x. So we are basically counting E of 0. Within the cardinality എന്ന് പറയുന്നത് that will be E of 0. Okay. So E of 0 is going to be equal to cardinality of A1 complement intersection, A2 complement intersection, AQ complement. So E of 0 counts the number of elements which possess none of the properties. So the number of elements in the set A1 complement intersection, A2 complement intersection, etc. AQ complement gives the number of elements which possess none of the properties. Now E of 0 is equal to omega of 0 minus omega of 1 plus omega of 2 minus etc. is minus 1 raised to q omega of q. So omega of 0 by definition that's how we have defined omega of 0. That is cardinality of S. Now omega of 1 is the number of elements which satisfy exactly one property. So that will be equal to, so x is said to satisfy the property of x belongs to AI. At a time one property satisfies only, that will be the cardinality of each AI. So that is I equal to 1 to q, and then omega of q will be summation over I less than j, cardinality of AI intersection aj. So it satisfies two property at a time. So that means x must belong to AI and aj. And omega of 3 will be summation over I less than j less than k, cardinality of AI intersection aj intersection k, and so on. Omega of q will be equal to cardinality of A1 intersection, A2 intersection, A. So therefore A1 complement intersection, A2 complement intersection, AQ complement will be equal to, so cardinality of S minus summation I equal to 1 to q, cardinality of AI less I less than j, cardinality of AI intersection AJ extra minus 1 raised to q, cardinality of A1 intersection, A2 intersection A. So that is the required result. now let us look at one problem. Okay, so find the number of non-negative integer solutions to the equation x1 plus x2 plus x3 equal to 50, where x1 less than or equal to 5, x2 less than or equal to 6, x3 less than or equal to 7. So, this is our first module conducting the problem of finding the non-negative integer solution. So, we will use the previous result. Corollaries ഉപയോഗിച്ച് solve this. For solving this, we will define sets and we will define properties on those sets. So let us look at the solution. Okay, അപ്പോൾ നമ്മുടെ set എന്ന് പറയുന്നത്, so let me define my set S to be the set of all x1, x2, x3 such that x1 plus x2 plus x3 is equal to 50. അതായത് എല്ലാ integer solutions. So take all the positive integer solutions to x1 plus x2 plus etc. x1, x2, x3 equal to 50. അതിനെ നമ്മൾ S എന്ന് എടുക്കുന്നു. We need to define different properties on our given set. So I'll take the properties P1, P2, P3. ഇതിന്റെ properties എടുക്കാൻ പോകുന്നത് x1 greater than or equal to 6 and x2 greater than or equal to 7, x3 greater than or equal to 8. Okay, നമുക്ക് greater than or equal to വരുമ്പോൾ we can find the number of integer solutions. അത് നമ്മൾ നേരത്തെ കണ്ടിട്ടുണ്ട്. അപ്പോൾ നമുക്ക് x1 minus 6 എടുക്കാം. So x1 minus 6 will be greater than or equal to 0. അതുപോലെ x2 minus 7 will be greater than or equal to 0. x3 minus 8 is greater than or equal to 0. So we will get in the form xi greater than or equal to 0. അപ്പോൾ നമുക്ക് integer solutions എത്രയാണെന്ന് combinations യൂസ് ചെയ്ത് കണ്ടുപിടിക്കാം. So I am going to take these as my properties. Okay, so നമുക്ക് x1 less than or equal to 5, x2 less than or equal to 6 and x3 greater than or equal to 7 വരുന്ന കേസ് കണ്ടുപിടിക്കണമെങ്കിൽ that will be the number of elements which possess none of the properties. So at the end we need to find what will be E of 0. Okay, അപ്പോൾ അങ്ങനെയാണ് നമ്മൾ proceed ചെയ്യാം. Okay, so let us write that much. So let S be, so this will be the universal set in this case. So let S be the set of non-negative integer solutions of x1 plus x2 plus x3 equal to 50. So S is equal to set of all a1, a2, a3 such that ai belongs to n plus and a1 plus a2 plus a3 is equal to 50. And let us now define the properties. So an element a1, a2, a3 of S possess property